Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when we upload it. And guys, don't forget our policy: do not skip any part of this video. This is for your own advantage, and ensure that anytime you are set to watch and to learn new concepts from this platform, avoid every unnecessary distraction. Then finally, if there be any part of this video you do not understand, maybe when you watch it for the first time, guys, you have the singular opportunity to replay the video over and over again until you understand the full content. Now guys, let's get to work. We have been looking at differentiation of functions, and now we are currently going to be looking at differentiation of product functions. We're going to be looking at differentiation of product functions very quickly. And in differentiating product functions, we have if y is equal to uv, where u and v are both functions of x, then dy over dx is equal to u multiplied by dv over dx plus v multiplied by du over dx. Of course, anyone can come first. The relationship between the first term and the second term is communicative. Therefore, anyone can come first. Now, if this is understood, the next thing we are probably going to do is to break down this equation too. What do you do in product rule when using shortcut? Unlike chain rule or function of a function, we only have one function of x. But in this case now, we have two functions of x. All you simply do is put down the first function, multiply by the derivative of the second function, plus put down the second function, multiply by the derivative of the first function. And that's exactly what this model or this equation that we have is all about. And to question number one. Question number one, we are given that y is equal to 5x plus 3, all multiplied by 3x minus 2. So I have dy over dx is equal to, like I said earlier, when dealing with product rule, like I have it now, this is product rule because this function is multiplying another function. So the relationship between the first bracket and the second bracket is multiplication, which is equally product. And that's why we term this as product rule. And it is your own duty to identify the relationship between the functions that you are given. So based on what we have here now, since the relationship between the first bracket and the second bracket is multiplication, we are dealing with product rule. This is when product rule comes in. Now in this case, all we need to do is to take this as first function and take this as second function. Are you with me? So the shortcut is put down the first, differentiate the second. Are you there? Then plus, put down the second, differentiate the first. Now, what is the first function here? We have this as 5x plus 3. Now, what's the second function? The second function is 3x minus 2. Now, when I differentiate 3x, I have 3. When I differentiate minus 2, I have 0. So the differential result of this is 3. Then I'll put down the 3 to multiply the first function. That's all. Then plus, the next thing we are going to do is to put down the second function minus 2. Then we will now differentiate the first function. And what is the first function here? The first function is 5x plus 3. When we differentiate 5x, we have 5. And when we differentiate 3, being constant, we have 0. That means when we differentiate 5x plus 3, the answer is 5. Then we will multiply this by 5. It's as simple as this. So at this point, I will expand or remove the bracket. 3 multiplied by 5x, this will give us 15x. 3 multiplied by 3, we have this as 9. 5 multiplied by 3x, this will give us 15x. And 5 multiplied by minus 2, this will have given us minus 10. Then the final answer here is to what? See if you can add up like terms or subtract like terms. Of course, 15x and plus 15x belong to the same family, and that will give me 30 if I sum up the two. This will have given us 30x. Now, 9 minus 10 being constant, this will have given us minus 1. Guys, This is the answer to this very first question. Understand that this lesson is mainly for objective students, and that's why we are using shortcuts. Okay, now, number 2, we have that y is equal to 1 plus x multiplied by what? 3 minus 5x. So first is to identify this is first function, this is second function. Then I have dy over dx is equal to pull down the first function, 1 plus x. Then differentiate the second function, which is 3 minus 5x. Now, if we differentiate 3, we have 0, and if we differentiate minus 5x, we have minus 5. Therefore, we are going to multiply this by minus 5. This is it. Then plus, let's give a space, pull down what? The second bracket, which is now this minus this. So we pull down the second function. Now differentiate the first function, which is 1 plus x. When we differentiate 1, we have 0, but when we differentiate x, we have 1. And 0 plus 1 is 1. Then we multiply this by 1. So what you do in shortcut, pull down the first function, differentiate the second function, and use the result to multiply the first function. Then plus, pull down the second function, differentiate the first function, and use the result to multiply the second function. It's as simple as this. Then guys, what do we have here? All we simply do is to clear up the bracket. 5 multiplied by 1, we have minus 5. And minus 5 multiplied by x, we have minus 5x. Plus 1 multiplied by 3, we have 3. And 1 multiplied by negative 5, we have negative 5x. So at this point, negative 5 plus 3 belongs to the same family, and that would have given us negative 2. And negative 5x minus negative 5x would have given us what? Negative 10x. So minus 5 is minus 10. This is the answer to this question. It's as simple as this. But this is subjective. You can be asked to factorize. Maybe when you check your option, you discover that you do not have any of this question, because the interest of any student is to have one of the options after you have provided the solution to the question. You must have one of the options from A to D or from A to E. Now, if that is the case, so when you check and you discover that you do not have anything like this, then you can factorize this. Here we have minus 2 as a common factor. We can have this as minus 2. When you divide minus 2 by minus 2, you have 1. And when you divide minus 10x by minus 2, you have plus 5x. This is the answer. If you expand back, you have this. Alright? Now we have number 3. We have that y is equal to 5x plus 8 multiplied by 3x plus 8. All we need to do, the y over the x, is to identify the first function. Now this is the first function. So put down the first function, differentiate the second function. Now the second function is 3x plus 8, and when we differentiate 3x, we have 3. When we differentiate 8, we have 0. Then we put down 3 to multiply the first function. Then plus, put down the second function, which is 3x plus 8 now. And then differentiate the first function, which is 5x plus 6. And when you differentiate 5x, you have 5. But when you differentiate 6, you have 0. That means when I differentiate this first bracket, all I have is just 5. All I need to do is to clear off the bracket. And to have that done, simply multiply this bracket by 3. 3 multiplied by 5x, we have 15x. 3 multiplied by 6, we have 18. Plus 5 multiplied by 3x, we have 15x. And 5 multiplied by 8, we have 40. All we need to do now is to add up the constants and equally add up the linear function. So 15x plus 15x, these are giving us what? 30x. And 18 plus 40, this will have given us plus 58. We can equally factorize because 2 is common. It's as simple as this. Now let's look at question number 4. Like I do always explain, I said, when you know principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. It's as simple as this. Now we look at question number 4. We have y is equivalent to exponent 2x sine x. So what we do here is to differentiate. Alright, so at this point now we have the y over the x is equal to what? Now we have exponential function, then we have trig functions. So this is the first function, and this is the second function. Therefore, we understand that the relationship between the first function and the second function is product. Then we are going to use product rule. Simple as this. Now, what do we do when using product rule with shortcut? Put down the first function, differentiate the second function, and put down the second function, differentiate the first function. Now, this first function here is x exponent 2x. Now, when I differentiate the second function, when I differentiate sine x, we will have cos x. We have cos x multiplied by the first function. Then plus, pull down the second function, which is sine x. Now multiply by the derivative of the second function, which is 2x. Now when I differentiate exponential 2x, all we simply have is 2 exponential 2x. Then we have this as 2 exponential 2x. Then finally we clear up the brackets. This would have given us exponent 2x cos x plus 2 exponent 2x sine x. Now finally, at this point guys, all we simply need to do, we can stop here, but based on the fact that this is objective, you can decide to factorize out exponential 2x since we have it to be common term between the first term and the second term. Now we have this to be exponent 2x. So when I divide this first function by exponent 2x, we will be left with cos x. And finally, when we divide exponent 2x sine x, exponent 2x cancels exponent 2x, then we have 2 sine x. This is the answer to this question. Then finally, the last but not least, we have y is equal to x cubed sine x. Again, we have polynomial multiplied by trig. Relationship is multiplication, product rule. Then I identify that this is my first function, and equally this is my second function. Now, if this is understood, all I need to do is to have the y over the x is equal to, now pull down the first function, which is x cubed, multiplied by the derivative of the second function. Now, when we differentiate sine x, guys, we have this to be cos x. Then plus, pull down the second function, which is sine x. And now differentiate the first function, which is x cubed. And you understand that anytime you differentiate polynomial function, you simply pull down the power, then reduce the power by 1. Then this will have given us 3x squared. Then we multiply this by 3x squared. Then finally, this will have given us, when we multiply this out, we have x cubed cos x plus 3x sine x. 3x squared sine x. This is your answer. But for the sake of objective, if you check your option from A to D or from A to E and you find that this option is not there, or you see that all your options are in form of brackets, that is to say you need to factorize this. And what is common here, if we have x cubed here and have x squared, what is common is x squared. Then put down x squared. Open a bracket. When you divide this first term by x squared, you will be left with x cos x plus, when you divide this by x squared, you will be left with 3 sine x. This is the answer to this very question. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Now, the question number 6, which we have as the last question here, we are asked to solve y is equal to x squared cos x. Now, equally we have this as a function, a polynomial function multiplying a trig function. And that's to say, we are going to approach this question with product rule. And how do we do that? We identify the first function and equally identify the second function. Now, we have the y over the x is equal to, now pull down the first function, which is x squared, multiplied by the derivative of the second function. And when you differentiate cos x, guys, you have negative sine x. Then this will give us minus sine x. Then plus, pull down the second function, which is cos x, and now differentiate the first function, which is x squared. And when you differentiate x squared, you have 2x, then multiplied by 2x. Then at this point, when we multiply this out, we have negative x squared sine x plus 2x cos x. So we can decide to rearrange this and equally factorize. X is here, and we have x squared here. And x is common, so put down x. Then take this positive sign first. When we remove x from here, we have 2 cos x. And when we divide x squared by x, we have negative x sine x. This is the answer to this very question. So we have ended this session of this differentiation class at question number 6. Like I explained to you guys, listen carefully. These numbers of problems that we solved, they are not enough for us to be able to gain mastery. If you want to gain mastery over this aspect of differentiation, all you simply need to do is to visit your textbook or visit Google, where you will have access to multiple problems. But understand that with the little problems you have solved together, you will be able to get ideas to solve thousands of problems on your own. So guys, don't forget to subscribe. If you have not done so, share, like, and make your necessary comment, whether to ask questions, to appreciate the effort you have put together to teach you this, or to make suggestions. So you can quickly check the description below, where you will find the link to the next video, where we'll be looking at quotient rules. See you guys in the next class.